Hey guys, my name is Mark Schvetz and I'm a developer at Chariot Solutions. Now that we've all eaten lunch and we're in for something really cool, we've all heard the rumors about Deno. Some may have actually used it. Kevin Qian, our speaker, is a core committer. I have to be honest, I made sure that I'm moderating this talk. I'm going to stop talking now because I want to learn about Deno yesterday. So paste your questions into Room A Slack channel and upvote by reacting or whatever. And we'll try to answer as many as possible in the end. And without any further ado, here's your speaker, Kevin Qian.
Okay, hi everyone. I cannot see you because it's on Zoom, but I hope everything is good. Yeah, so yeah, because we're on Zoom now. I actually originally prepared a bunch of stickers, originally trying to give out if you're actually doing this talk in person. But yeah, I guess unfortunately I cannot do that, but whatever, let's just jump right in. So yeah, I'm Kevin. I'm one of the core contributors to Deno, and we'll be talking about Deno today. So yeah, let's get started. Okay, spotlight my video. Cool, let me get. So a quick disclaimer, as probably all the other contributors when they were doing talk also did, is Deno is still pretty much under heavy development at this moment. New users are welcome, but just be cautious because some APIs might change. But we also expect to have 1.0 released next month, mid-May. I think it's probably May 13th, I believe. But yeah, just probably keep an eye on that date and also be cautious about using the APIs and stuff. Cool. What is Deno? I'm not quite sure how many of you actually have seen the talk Ryan did 2 years ago in the JSConf EU, I think, when he first introduced his regrets about Node.js and mentioned about this new experiment he did called Deno. And it has been growing ever since, and after 2 years, it's becoming a much larger project than what was presented in this talk, that talk. So yeah, Deno is a secure TypeScript and JS runtime, and it's built on technologies like V8. We're using it through something called Rusty V8, which I'll explain later on. And yeah, we also use TypeScript and Rust. And we also use Tokyo for doing the event loop instead of libuv of Node. Maybe you heard about it. So yeah, this sounds very much like Node.js, right? Especially when you hear about V8, hear about it's a JS runtime, and you also have the event loop stuff. So why are we building this? Well, JavaScript has evolved drastically ever since 2009, which is when Node.js was initially presented. And there's just many regrets in Node.js that are just too late to change, which Ryan mentioned about it. He believed these are kind of bugs in his viewpoint, but now they're just becoming core part of Node itself. So it's too unrealistic to change stuff. Otherwise, we just break so many people's code. And there's also new tools and ideas flourish in the past decade. And there's also some concerns about security, which I'll also walk into it, talk about it. So yeah, let's just jump right in. How is it different from Node? So probably the very first thing that you'll notice with Deno is it claims itself to be a TypeScript runtime. So we basically provide TypeScript support out of the box. So basically, you're able to run TypeScript without zero config TypeScript by default. And you can just directly import a TypeScript module directly. You can just import something from a TypeScript file and also explicitly showing the extension .ts. And you can still run plain JS file just fine. It's a runtime also supports JavaScript and TypeScript both, so you don't need to worry about that part. If you don't want to use TypeScript. Yeah, it also has support with JSX and TSX, thanks to the TypeScript compiler we're using. And there's some small tricky parts, like you probably need to plug in this line, this Deno types, oops, I shouldn't click on that link. Deno types line, because there's some issues with resolving the any type of TypeScript. We kind of like disable implicit any by default. So you probably need this line to explicitly tell the compiler that the types of React and JSX stuff. But otherwise, it will be pretty easy for you to use once you add this line. And yeah. So we basically have a built-in TypeScript compiler, a full TypeScript compiler built in, and it is snapshotted for faster startup. I'll explain a little bit more about snapshotting, but basically it basically means we're putting this whole TypeScript compiler into the runtime with like minimal cost. And also we're able to do automatic recompile and caching. So basically when you're changing your TypeScript source file, we're able to detect this change and compile, like update it on the fly and only update the files that are actually changed. So it's pretty fast. And we also do the caching for you. So if you don't change your file, then rerunning the same TypeScript file would be like instant. And also we support an optional config flag for you to plug in your custom TS config. If you found the default config not the best thing you want, for example, you want decorators stuff. And we also have a few compiler API available at runtime. So you get something like Deno.compile, which compiles a list of files that you provide, and also transpile only, which simply just strip off all the types instead of actually like do the type checking as compile do. And you also get Deno.bundle, which just emits a bundle file given the sources. So it's pretty neat. You have all these things exposed to you just through the when you're using Deno. Cool. Another major thing I would like to mention about is like Deno's approach towards modules. So I'm not quite sure how many of you have heard about ES modules, because like I originally assumed many people will actually know what's the difference between ES modules and common JS modules, but it turns out my assumption wasn't quite right after talking with some other people. So yeah, so Deno supports only ES modules. So you're going to like write your imports using syntaxes like import from, and you have to explicitly provide the extensions. Like you have to tell if it's going to be a JS file, if it's going to be a TS file, or even if it's going to be a WASM file, since we also support importing WASM. So if you don't provide extensions, then we're just going to treat it literally. So we're going to say, oh, you're trying to import a file called it's called A. And there's some trickiness about how to decide on what is the type of this file, because you might want, for example, in the .ts file, you will actually trigger the TypeScript compiler. So it's become mandatory part of the import specifiers for you to provide extensions. So this also basically means there will be no required built-in. There's an asterisk there, so I'll explain it later on. But basically, our viewpoint is like, so first of all, require is this thing comes with common JS, and it is just like the resolution algorithm is just a little bit too magical. You kind of like resolve index.js and resolve modules from node modules folder. And you also look into package.json, which we feel this is just like a great overhead. And also like it's inherently in the part of like common JS stuff. And yeah, we just completely, we don't have package.json, and we don't have this required built-in, and we don't support extensionless import. So yeah, so one thing nice about the static import and export syntax compared to the require is that, so basically, when you're doing an import using the static import and export syntax, you're getting modules, you're getting name of these modules to import pre-evaluation. That means when you're trying to import a file and you try to run the script, and instead of just like sequentially pulling, like taking in the source of these modules, so what will actually happen is when the runtime, when V8 sees the import specifiers, they will first try to fetch these like modules asynchronously and probably in parallel, because it will be able to see, like, for example, you have 10 import statements. They can just directly try to get the source code of these 10 separate modules like in parallel. And this thing can be a recursive like tree resolution thing. So it works pretty well with URL imports, because you're not going to be able to know like a lot of information about which file is actually going to be imported. So it will need to resolve it in an asynchronous manner. And yeah, because it works well with URL imports, and we think it's pretty nice. And basically, this also brings us into a really important part of Deno, which is URL imports. Yeah, so basically, you're able to kind of like just import like stuff from URL, and you can run script directly from a URL, which is actually pretty nice. I mean, I can probably do a really short demo about this because it's going to be simple. So let's see. So yeah, so let me just clear the screen for everything. Okay, so we have our Deno binary here, and you're able to do something like, I'm just going to provide a simple URL for Deno, like we're going to call it deno.land/std/examples/welcome.ts, which this is the file kind of like hosted on this URL. If you like click on this one, yeah, yeah, it will show this file, like basically download this file with the single line console.log, welcome to Deno. And we're able to just run it directly in the command line. And it will just download the file for you and run right away. So it's pretty neat. So you're able to kind of like, yeah, let me switch back to the slide deck. Oops, not what I want, that bar. Yeah, and similarly, you are able to just import stuff from the URL, and we will be implicitly downloading these files for you and compile them. So this is essentially more like having a built-in package manager of Deno. You don't need like a centralized registry or hosting. You can just provide URLs, and it will just work out of the box. And also, there's one good thing about it is like, you don't need to download unnecessary files that like you're not going to use, or they're just simply not runnable. For example, README files, and which is kind of like sometimes downloaded when you're installing npm packages, because they're just kind of installing everything that is considered part of the package. But for us here, we just only pull down files that you're actually going to use. So yeah, URL imports, they're fetched. The files that are imported using URL are fetched on first run, and they're cached locally and never updated. So you're able to control your cache location using this interesting environment variable called Deno_dir. So it does feel like Go path or some other things, probably if you have, like some of you used Go before. Yeah, you're able to control your cache location. So this basically means we'll have a implicit global cache location for easy development. And you'll also be able to explicitly specify the node, the Deno_dir, when you're doing things in production. For example, you're probably just going to ensure that files are not going to be changed without your notice. You can probably commit some of the files dependencies that you're actually going to be used along with your source files, so that to ensure immutability. And if you want to kind of like update the cached like version of some of kind of your dependencies, you can explicitly provide this --reload flag, or the shorthand like -r. So this basically tells Deno, please, like when you see these URL imports, like please try to force re-download them instead of using the local cache. And it also supports partial reload. For example, you just want to reload some modules that are hosted under certain hosts or just under some certain path, and you can provide a like I just want to reload stuff under that with that URL prefix. And there's also an interesting thing called Deno -- cache only, which forces Deno to not pull down new dependencies when you're running your script. For example, when you're running your script under an environment where there's no network, but then you already have all your dependencies already cached, you bring your Deno, you're sure that things are present in the Deno_dir. So you can use this cache only thing. To force using local cache, fail if not cached. And there's also a command called Deno cache, which basically caches all the remote modules that you're going to be used without actually running your script. So this is the way where you download these modules. And this thing had been just recently renamed to cache. It was called something like fetch before. So if you see some docs mentioned about Deno fetch, well, now it's called Deno cache. Okay, so there's one more interesting thing about the import stuff. It's called import maps. So basically, for example, you might find typing the URL kind of really boring sometimes. I mean, it's kind of really long and not easy to write. Sometimes I've seen people doing some other kind of solutions. You can probably create some file called deb.ts file to import all the remote modules and re-export them so that other of your files can import from the debs.ts. So kind of making the import kind of shorter when you're writing your script, but that's probably one of the solution. Another solution is the import maps that I've been mentioned here. So this is a ongoing proposal with the web standard, and it currently has some experimental support in Chrome. So basically, this thing will allow you to provide custom import specifier mappings. So I'll probably show how it looks like. So you're able to provide something that looks like this JSON file, and you can explicitly say, okay, I'm going to have, if you ever see this HTTP / thing, please remap this thing to this URL. So basically, once you provide this import map by specifying this import map in the import map flag, then every single import in your file that looks like HTTP / will be remapped on basically replacing this HTTP / prefix with this one. To actually resolve the module. So this has some quite interesting benefit, basically allow you to have shorter specifiers when you're running your code, and also allows you to delegate your version control to third party when necessary. For example, you feel it's probably really complicated for you to manage yourself, or there's some other complications, then you're able to delegate them outside, because then this third party, probably there's going to be a third party package manager if you want to use. It can just inspect this import maps file and add or replace entries. So it will be transparent to you, transparent to your code when you're actually using these modules. And it also provides the benefit for easy mocking and overriding. For example, when you're in your test environment, you can provide a different import map file so that you can, kind of having some kind of fake modules with fake data. So it's going to be a boon when you're doing testing. Cool. Another thing that's really different from Node is the API design of Deno. So principle, promise everywhere. So instead of relying on callbacks, all async operations are now returning a promise. So this is one of the regrets that Ryan has been explicitly mentioned in his original talk of Deno, and this idea hasn't been really changed. We just kind of follow this idea, because Ryan was originally saying that he originally do the callback style instead of using something like promise was simply because he don't want the overhead of extra objects. But it turns out just causing so many issues. And the JavaScript engine has been improving ever since. So it's like the overhead is kind of minimal. And we have really nice, we're now, especially after the landing of the async await, async await in JavaScript, it is just kind of like really easy for you to write asynchronous code, like using the async API. So yeah, and we also support something called top level await, which is actually supported in the latest version of V8, the JavaScript engine. But I'm not quite sure if Node has updated to that version. I'm not quite sure. Maybe they did, but yeah, we kind of like updated the V8 to support top level await as soon as it becomes kind of like stable in V8. So now you're basically able to just kind of like write on the top level of your module await instead of wrapping it inside of an async wrapper. So it will look much nicer. I think there's also some like things against top level await when people, I think there's a article saying about the foot gun of top level await. But I think that article, the issues with that article has been addressed pretty well. So like, yeah, this thing has basically going to become part of the standard of the new JavaScript. And also another thing that we have been doing is we have been employing like the TypeScript and use a bunch of like TS interfaces. And some of the interfaces might look really familiar to the Go lovers. Like we have reader, we have writer, closer, seeker, all these interesting combinations. And we find this kind of like abstraction really nice. And yeah, we found it really nice. And also pretty intuitive for you to use them. And yeah, you're able to plug in like things kind of like implements the interface in your code, so it's pretty nice. Yeah, and another part of our API design changes is that we have been using async iterators and generators pretty heavily in our in some of the API designs, and especially in some of the standard module stuff, which I'll also explain a little bit more later on. What is Deno standard modules? Yeah, but basically you have something syntax looks like for await, which kind of like iterates something something that, like, for example, when you're having HTTP requests, as if you're iterating a stream of HTTP requests and respond to each of them using a simple for loop. So it's really nice, like syntactically, and I think many people like it. And I can probably actually show it how it works. And yeah, actually, let me just use the files here. So I have already prepared this file, like exactly the same code as shown here. So you just import serve from this URL, and you serve on port 8000, and you just iterate on all the requests, which as they comes in. So that's what you have this await syntax here. I think this thing is still not yet actually a part of the JS standard, but it's already implemented in TypeScript, so you can use it right away. And yeah, then if you like, actually it's like pretty annoying for me to switch demo and demo3.ts, and I should be able to have that server up and running on port 8000. Yeah, and it serves pretty well. And basically, when there's new requests coming in, it will just like handle these requests asynchronously. And yeah. So another really important part about our design in Deno is that we have been thinking about stuff about security ever since day one of the project. So why we are talking about security here? So yeah, technically speaking, your like Node.js does not really have anything like built in about like the security model or stuff similar. So Node.js basically allows your code to do whatever you want. For example, removing everything. remove -rs, everything. This may sound okay, but this is especially problematic when you are using some kind of untrusted packages. Like, for example, if you heard about the incident with the event stream package, I think last year or 2 years ago, I forgot the exact date. So basically, there was some malicious package called event stream, which kind of like overrides one of the Node crypto API and stole your cryptocurrency keys and send them to some remote server. Like, you don't even know about that. And the problem is, like, this package was one of the dependencies of PS3, and it also got somehow sneaked into things like Nodemon, like the really popular. So it's kind of like just, even if you think you're going to trust Nodemon, you have to have this kind of implicit trust on packages like event stream, which might just, in this case, steal your cryptocurrency keys, which is bad, right? You don't want your keys to be sent to some remote server that you don't even know about it. So this is also especially true with the case of Deno, because Deno supports URL imports. So yeah, like basically in some sense, like similar to what you do with like scripts you loaded into the browser and similar stuff. So one really important part of the Deno design is Deno is a sandbox by default. So instead of like showing this slide, I'm actually going to just type some. When we're talking about sandbox in default, which this basically means that Deno won't be able to allow you to do many of the common like file system and network stuff by default. For example, if you want to read some kind of file, for example, I'm going to create a single file called await read file demo4.ts. So I'm just going to read myself. Yeah, actually, let me just move my window easier for me so that I can just run the command easier. Okay, let me kill the web server. Real demo. So yeah, demo4 is this single line about we're going to read this file. And if we try to run it in Deno, you'll see this like pretty scary warning saying, okay, uncaught, permission denied. Read access to this thing is kind of not allowed. Run again with the allow read flag. So this basically means Deno will basically kind of like work as a sandbox. Like it by default does not provide you with any kind of like read, write, network permission unless you explicitly specify them. So if you go to the Deno run h, you'll see there's a bunch of flags. Like we say there's flags like allow all, allow m, allow hr time, allow net, read, run, write. So basically, when you're running a Deno script which is going to do I/O or like doing network request or want to have high resolution time, you need to explicitly tell Deno that I'm allowing this script to do certain stuff with these like flags. And for example, like read and write and net, you're able to explicitly provide the paths you want the Deno to be able to read and write, and also the like network hosts and probably like IP addresses. So in this case, if we're going to have some packages like event stream, as I mentioned before, that package won't work because you don't specify that you are allowed to send network requests to that server, which your cryptocurrency keys are supposed to be sent by that package. So that issue is not going to happen. But so yeah, basically in the case that we have just now, you're able to basically say, I wanted to allow read equals just current directory. Yeah, current directory. And yeah, it doesn't print out anything because I didn't write any code to let it print out. But basically it runs to completion. So I mean, I can actually just console log the whole thing. New text decoder dot decode. Yeah. Yeah, it works. It prints out the file because we explicitly tell Deno that we will allow it to do this thing. And if you're just doing your own like local development and you trust everything that you write because you write them and you don't really use some kind of untrusted packages, the packages you don't trust and then like imports, you can have a kill all switch like this basically -a, like the allow all thing, and it will bypass all the permission checks. And yeah. So besides having these kind of like permission related stuff when you're specifying in the command line, we also have runtime permission queries. Because, for example, when you're sometimes trying to write or read into a file in the scripts, you might not be able to know the exact path of this file beforehand. So it might only be determined during runtime, or if there's some kind of I/O based on what user input. For example, you're going to say, yeah, for example, you want to write a simple script that kind of accepts user to type in some kind of path and print out that file in that path, then you won't be able to know like the exact path beforehand. So you cannot really specify them as part of the permission flags. So in that case, we have something, we create something called the permissions. We technically not we created it. It's actually a part of a proposal called the permissions proposal, also about web standards. So that's why you see it's hosted under W3C. And we kind of find it really handy, so we just use it. And it basically allows you to query if I'm able to do certain stuff on the runtime, during the runtime. And you can basically handle it depending on if certain operations are permitted. And you can also dynamically request for new permissions as you need them. And let me just, instead of like showing that slide, let me just do a live coding in similar ways. Like, yeah. Okay, so for example, that's I'm going to deno.permissions.request. So let's say that we want to request a read permission of the current directory. So we're going to do something like await deno.permissions.request, and I want to request for like read permission under the current directory. And based on the status, there's status.state, which there's some different states of it, and one of them is called granted. Basically means that the user explicitly grant saying that you're allowed to do that. Then we can, for example, just console.log our text decoder.decode. Let's say we want to also, again, read the current file. So I think it's called, is this file demo4? Yeah, demo5. Let's say I want to just read this file, print it. Otherwise, if the user says, I'm not going to grant the permission, then we can just maybe just console the error. Maybe it looks nice to say no permission. Okay. Let's run this script. So pay attention that I'm, let me just make it larger because I'm not quite sure if they're too small. So yeah, if we just now run this script without providing any kind of like permission flag specified, like we're not saying we're going to allow beforehand that user is able to read in some directory, then we'll get this interesting prompt saying, okay, so the user is trying to request read access of the current directory, which is this like real demo directory. And it's explicitly asking user, do you want to grant this? Do you want to grant this permission? And if I say grant, then cool, we're going to have the thing printed. Otherwise, if I say no, then yeah, no permission. So basically allow it to handle it like based on what the user decides on during the runtime. Yeah. Another thing we have been really emphasizing on when we are designing Deno is we want really nice browser compatibility. So in some sense, you can understand Deno as something like a browser for scripts. So we're having like pretty extensive web API support. And we also believe in that we shouldn't reinvent APIs if there exists some web compatible counterparts. So if you like open up a Deno like REPL and you type in, yeah, the first thing you probably would notice is that the global object is also called window by default, which is the exact name you'll get in browsers. So you can print, yeah, this prints out all the global stuff that actually, yeah, the reason why it's showing kind of like a little bit like annoying here is because it prints out everything in the Deno namespace. But otherwise, you see some interesting like stuff like Q microtask, A to B, B to A, fetch. Yeah, this is interesting. We have built-in fetch. So it works pretty much like the fetch you have in the browser. And you also have some other things like, yeah, crypto, onload, unload. And this basically means we also support something like event target, which is the, yeah. And also similarly, that's the reason why we have this like new text decoder or encoder stuff, because they're also part of the APIs you get in the browser. And we feel that we don't really need to reinvent things that does similar features. So we kind of like just having refile returning a uint array, and we're going to use the text decoder to translate them into strings. So yeah. So one thing that is really interesting is that all Deno APIs are going to live under the Deno namespace. And that is the reason why every single time when I was doing some kind of like API that requires things like file system, you'll see it through like deno.read file. Everything is under this Deno namespace. So this means you can always check if window.deno is present to decide on what the behavior you're going to do. So this basically allows you to do better code sharing between the browser and Deno. So for example, you have some script that will do optional logging depending on if you're running it on the server side. Then it can just check if the Deno namespace is present and do the logging. Otherwise, if it's in the browser, it can probably just store something in memory instead of doing the login to the file system because it doesn't have the Deno namespace. This also means, yeah, actually, actually that's probably what I want to talk about here. Yeah, okay. And if you print out the Deno namespace, you're going to see a bunch of like pretty familiar names, like all the file system APIs you probably want. And because like Deno recently changed the like how they log stuff to align better with what Node does. So it's just getting longer and print out all these function signatures. But yeah, there's a bunch of really a bunch of like file system APIs, network, IO stuff under this Deno namespace. Everything like that is not supposed to be present in the browser is supposed to be under Deno namespace. Yeah. So we also have a really early decision to kind of like support web workers, because this is how you do like userland JS threads. And so yeah, we have built in like you can spawn a worker. We have worker as part of like the exposing the global object. And yeah, so currently we don't have access to the Deno namespace in workers by default, but I think this thing will be changed pretty soon, that we'll probably provide some options that allows you to turn on the Deno namespace in the workers. The reason was like the original reason why we don't expose the namespace was like in the browser, workers also doesn't really like, yeah, in the browser, workers are kind of like, yeah, this is actually a pretty debatable decision, but otherwise, anyways, we'll be able to like allow you to import Deno namespace in the worker pretty soon. Like it's work in progress. And we are trying to align this worker API as close to the browser. Yeah. Another really interesting thing about Deno is tooling. So in some sense, Deno aims to provide an all-in-one solution. So yeah, if you go to in the Deno, and you can show all the subcommands it has. So Deno has a bunch of subcommands. So by default, if you don't provide a subcommand, it will try to resolve using like Deno run, which is like running a program, like what you would usually expect. But we also have a huge bunch of different other subcommands. As you have seen here, we have bundle, we have cache, completion, doc, eval, and I'll walk into some of them later on. So yeah, Deno bundle. This is basically just allow you to bundle like your scripts into a single like bundle, and it will resolve all the URL imports, all the other imports you have in the file, and try to bundle them into a single file. It's done through the TS compiler, and it's like functionally pretty close to the Deno.bundle runtime API that I mentioned before. So, and you also get something called Deno format. So we have a built-in formatter. It's based on something called dprint. It's a pretty fast code formatter. It also kind of like both have Rust and TypeScript APIs, and we found it just blazing fast, I have to say. Like originally we used like Prettier, but then we just kind of like switched it for this dprint stuff. So if you kind of like just copy this command and you run it, it would just do the format right away. And it's pretty easy. It's becoming part of the Deno itself. Yeah, this formats the standard in. You can also format files. And I think it also provides you with a glob, like allow you to do pattern matching if you provide like glob paths, something like that. And there's also something called Deno info, which is kind of a built-in dependency inspector inside of Deno. So yeah, for example, if you have some kind of like script hosted on some domain, some hosts, and you want to know which other files this simple script is importing from. So for example, we're going to look into a file called server.ts. Let's just do this. Yeah, so it will just kind of like, so we say we want to know the information about this single file, like what's it, and it will kind of like first, yeah, definitely download all these files because like they're never present locally before. So yeah, and you'll see this interesting logs here. You can see the whole dependency tree. You can see that this HTTP/server thing imports something called encoding/UTF-8, and also like buff.io.ts, which also itself importing from other files. And you can see the whole dependency tree by using Deno info. And you can also see how this file is, where this file is cached locally, and all its compiled version and the source maps, and also the types of this file, TypeScript. So yeah, the one interesting thing about this is that this thing works also for scripts that are not like intentionally written to be run on Deno. It can also work for scripts that are expected to be like imported in the browser context. So I think I have a URL somewhere which can be interesting. Yeah, for example, there's some website called like to do MVC stuff, and there is one script called bootstrap.mjs that is used by this website, and you also want to know how does it import. So I can just copy this URL and Deno info it. Yeah, and you can see its dependency tree. So it can be handy even if you don't like directly use Deno, like you still use Node, but in case of doing some kind of like front-end development, yeah, this is still pretty useful, I would say. And we also have some like subcommands called Deno install. So this basically allows you to install a script as a local executable. So let me just copy this thing. It's just too long for me to type. Yeah, so basically you say, I want to install a script called file server. Like this, there's a URL called like deno/stt, and there's something called file server.ts. And I want to be able to run this file as if it's a command. and with certain permissions like allow net and allow read. So in this case, you're just going to do like Deno install and provides the permissions that you want this script to be had when it runs, and name it to file server. So what will happen, it will just pull down all the like scripts it needs, and it will, oh, existing installation found, aborting. Yeah, so it will also check if like something is already previously installed. So I can just force override. Let's just override it. Yeah, cool. It overwrites, and now I'm able to do just kind of like file server. Yeah, you can run it directly as a command and can follow this link. And yeah, a basic simple static file server. Okay, let me just jump back. Let me kill the server. Wait, where is the, okay. Yeah, it just can be really handy for you to like install some local, some script other people write locally, and yeah, run it as a command. And we also have a built-in test runner. So we have this function, this method called Deno.test. And yeah, you can just provide your test there, the names, and if the test should be ignored or some sort. And these tests will be triggered if you call Deno.run tests, or if you just use the Deno test subcommand. And yeah, it's a pretty small like test runner. But I think it should be pretty useful. If you don't really need some other fancy features, like we're thinking about probably implementing something like before all, like something you might see in Jest or some other things, but that is probably not going to be 30 minutes. Okay, it goes longer than I thought. Okay, I'm gonna be faster later on. Yeah, we also have a subcommand called Deno.doc, which basically allows you to just give it a file and generate some really simple doc for you to view. Yeah, something like, I can just copy it directly. So yeah, so suppose we have this server.ts file, and you can just directly have the doc nice formatted for you in the command line. And it also provides some other flags for you to export into a JSON format, so you can render it on the browser. So this is the way where we generate our current Deno docs. We have this doc.deno.land URL, and it allows you to just kind of like resolve some files that are present in the on the web, and it can just generate docs like dynamically. Yeah. And then we have standard modules, which is yeah, this is a really important thing, so I cannot really skip this section. Yeah, so when we are using Node.js, we have this problem about library fragmentation, because like the built-in modules of Node is actually pretty few. And so the Node community like turns into kind of like they're really working on adding more utilities and publish them onto npm, which is pretty awesome. But then you get your dependency tree explode very easily. You're going to rely on thousands of small packages, even if you just want to use React. And you're going to have a lot of code owners you don't even know in your dependency tree. And some of the packages might just sometimes just go away. And it's kind of really annoying, like the left pad incident many years ago. So, but we still think like the small core is really nice. So we, because small core allows you to get a small executable for faster startup, and you don't need to pay the cost if you don't need some extra utilities. So we kind of go with this idea about creating something called Deno standard modules, which are modules that are hosted under /std of Deno.land. So it's kind of like maintained and vetted by the Deno contributors loosely based on the Go standard library. And you can just import them like using URL imports when you need them. And you're also able to specify a version using this like at v0.4.0 to ensure that this version of standard library complies with it's going to definitely work with the current version of Deno you're installed. Yeah, use it to log versions. And we have currently we have this bunch, but this is definitely going to grow later on. And ecosystem. So Deno packages tools are still growing. So we have some kind of well-established packages like Oak and which is like a code routing, provides routing support and like running servers. And we also have a VS Code plugin. We have more things available in awesome Deno. And we have something like third-party registry and also something called Pika CDN, which works pretty well with us. And yeah, I'm probably going to skip this one, and you can look into it. So NPM packages. Many people still want to use NPM packages because like there are just so many of them, and our ecosystem is still growing. So it'd be nice to use some of the NPM packages before their corresponding ones in Deno like appears. But the problem is like it has the common JS module system, and they also have like incompatible API. So our solution to this is we create something called std/node, which is it provides a optional common JS loader module loader. So it's not built into Deno itself, but you can import it, and then you're able to require some of the node built-in modules, those polyfills, using the require that it created from the optional CommonJS module loader. So something looks like this, like you create require, and then you get a require function, and you can require stuff from the built-in, the polyfills, or extensionless modules, like which I complained about before, and also it visit node modules. So yeah, it's still work in progress. There's still a lot of functionality missing, but the module, at least the CommonJS, the module loader is available there. So originally I want to talk a lot about the TypeScript, about the internals of Deno, but I don't think I have enough time. So I'm just gonna quickly go through it. So Deno is written in Rust instead of like C++, which is mostly what the backend of Node is written in. We think it's pretty nice. It's no longer in Go. The original prototype was in Go, but now it's like in Rust fully, and it has pretty nice properties like memory safety and some kind of thread safety things built into the language itself. And it also had no GC, so we don't want to have double GCs. So that's why we kind of switch from Go to this. And the basic underlying architecture of Deno is that Deno does not it has really limited direct binding to V8. So instead of doing a lot of bindings from the TypeScript side to the to V8 and similar stuff, we just use a really few bindings, and the most important ones are called send and receive, which is basically like on the TypeScript side when you're trying to do an API call, for example, some file system API. What it will do is it will just kind of serialize your request and send it as a message through this send channel, and then the Rust side can receive this message and process it, and probably also doing some async operations. And once it's done, the TypeScript side will be able to receive it. So this is kind of like a message-based architecture instead of doing a lot of direct bindings as Node does. And also Rust has this thing called future. So it's like promises, but I'm probably not going to walk too deep into it because we have no time. And yeah, deno.core.send receive, which is this is the send and receive channel that we have. And there's also some V8 magic we use here. So Deno has been using V8 snapshots pretty heavily. Let me see the time. We still have 7 minutes, so I think I'm gonna do with the snapshots thing because it's still really important for us. So Deno uses V8 snapshots, allowing you to kind of take a snapshot of a bunch of TypeScript, the JS code, so that when you're going to run the Deno, so the bootstrap code of Deno is not going to be parsed and going to be parsing is a lot of overhead. So instead, we just kind of take a snapshot of what currently is already available on the V8 heap, so we can resume execution from a previous state where a bunch of code has already been loaded onto V8, and it allows pretty fast startup for Deno compared to Node, because Node still need to run a bunch of bootstrap JS code when it just starts up. So this is what the architecture currently looks like, but yeah, I'm gonna skip this. So we're also now able to have people to write native plugins for Deno, but it's also going to be based on the message architecture. So basically, you'll be receiving, you see, when you're trying to add a a native plugin to Deno, you're going to write functions that takes in two parameters, like both of them are kind of like a buffer. And you'll be like serialize and deserialize on either side and kind of like process it and handle it. So that like the way you can write an API, this API is like pretty minimal. You don't need to deal with all the complexity about V8. And yeah, this is also the first version of the native plugin. So we're probably going to improve it later on, but yeah, this is the basic idea how you do an like message-based API, a message-based native plugin. And you're also able to build your own runtime using what we provide in Deno. We intentionally split Deno into multiple crates, and one of them is called Deno Core. So it provides with the underlying Deno message passing infrastructure, but removes all the Deno like, for example, those APIs for doing I/O, and you can just build from scratch your own runtime using Deno_core, and you don't need to worry about V8 stuff because we just kind of like hide everything for you. And if you really want to use V8, well, you can. We also have something called Rusty V8, which is the Rust binding. We have for if you want to like create the runtime from scratch, but you want to use Rust. So we create this thing and we've been using it, and it's pretty nice. Yeah, so Deno is still a pretty young growing Dino, so that's why it's called Deno. Actually, it also might be pronounced as Dino. Some people like that pronunciation, but whatever. So there's still a lot of things we need to do. We want to improve the inspector. And we also hope we can implement something called Deno Compile in the future, which allows you to create custom single binary. So instead of shipping scripts, you can able to just ship a binary and people can run it right away. And also there's some other things that we want to do. Yeah, extra fun, join us and contributed. And that's it. Okay, I made it in time. Cool, thanks.
Wow, that was so close. So close.
Yeah, I was like, I'm so sorry. Like I didn't pay too much attention. Like,
fantastic. So
yeah.
we're gonna have to hop off in 3 minutes because I have to start moderating the next talk. But you guys head over to the Deno channel. Kevin said he's gonna plop a copy of this presentation in there, and you guys can ask him questions. I'm sure you guys have tons of questions. So you have 15 minutes to ask any questions, and yeah, please, you know, keep in touch. And thank you so much, Kevin, for speaking at our conference. You really made it that much better. Thanks.
Yeah, thanks.